All right, everybody, so welcome to your intro to classifying polynomials, also adding and subtracting polynomials. So first, let's go through some vocab here. So a term is a mathematical expression, and it's usually separated by addition or subtraction. Okay, so some example of this could be like just a term could be 6x cubed, 9, 100, x. Okay, so now coefficient is a number attached to a letter, also known as a variable, through multiplication. Okay, so for example, the coefficient of this first one is going to be the number attached to the variable through multiplication, which will be 9. And then this one, number attached to a letter or variable through multiplication, so 4. All right, so we have a constant is a number all by itself. So it's like that Celine Dion, all by myself. Anyways, so a constant, 7. Now 5 is a coefficient. 2 is a number all by itself. Okay. So a polynomial is a mathematical expression made up of 2 or more terms. Sorry, had a blank there. Okay, so you see here's like a fancy definition, Now, some examples of a polynomial. You have to have at least 2 terms, okay? So it could be like 6x to the 5th plus 9, okay? Or it could be 6xyz plus a. Or what about, here's a good one. 2/3 x to the squared y 5th minus a, b, c to the 2nd. All those are polynomials. We can even add one more. Plus 10, just to be fancy. Okay, so then you have different classifications of polynomials. You have a polynomial that has one term. It is called a monomial. Monomial. Sorry, I always spell it wrong. Then a polynomial consisting of 2 terms is going to be called a binomial. And then you have a polynomial consisting of 3 terms is a trinomial. All right. So those are our classifications. You do need to know these. Okay. What a monomial, a binomial, and a trinomial are. So now you have the polynomial m cubed plus 8m squared minus 10m plus 5. How many terms does this have? Well, remember, terms are mathematical expressions separated by addition or subtraction. So we have 1, 2, 3, 4. Okay, so it has 4 terms. Now, the first term we see is m cubed. What is the coefficient of m squared? So we're going to locate m squared, which is right here. And what is the number attached to it through multiplication would be the 8. Remember, the constant is a number all by myself. So 5. The variable is the letter. Okay, remember that. So our variable is going to be m. Now the highest exponent. So remember, exponents, if you have like a little a, it's the number up here. Okay, that's your exponent. Okay, so your highest exponent looks like it's going to be 3. All right, so let's do another exercise. We have identified the terms and coefficients of each polynomial. So I would pause this real quick and try it for yourself to see how you do. Remember, you have an eraser. You can erase as needed. Okay, so go ahead and pause the video and try it out. Okie dokie. So you're coming back and you're trying your answers, or you're checking your answers. Sorry. So the number of terms, we have 1, 2. Now coefficients, remember, they are the numbers attached to the variables through multiplication. So -2 is 1 and 100. Okay, so look at your terms. How many do we have? 1, 2, 3. Coefficients, remember there's like a little invisible 1 there. And then 4. Next one we have 1, 2, 3. And their coefficients are going to be 4, -2. Oh, and that's it. Because 5 is a constant. Why? Because it's all by itself. I don't know if you guys are old enough to know that song by Celine Dion. All right, on to the next page, everybody. The degree of a term is the highest exponent. Okay, so if you look at 5, trick, because the x is actually to the first power, remember? So we're looking for the highest exponent. So the highest exponent in this example, if that's to the first power, would be 1. It's the highest exponent attached to a variable, okay? So if you look at the next one, it's a constant, which means, guess what? We don't have a degree, okay? It's just a constant. All right, so the degree of a polynomial, so notice this was the highest of a term that we just did. Now we have of a polynomial is also the highest exponent that you see. Okay, so for example, you have 3x to the 4th minus 2x cubed plus 6x squared minus 7x plus 9. We are looking for the highest exponent. Well, here's a 1, here's a 2, here's a 3, a 4. So our degree is going to be a 4. Now, I would like to make one thing very, very, very clear. These polynomials are not always going to be in order. Okay, so do not make the mistake of being like, oh, it's the first exponent that I see. No, these are not always going to be in order. Okay, so make sure if you don't have them in order, you put them in order first, and then you select your highest degree or your highest exponent. All right, so a polynomial written, in standard form. Okay, that means that the exponents are written highest to lowest. Alrighty, so you see this one, we have 4, 3, 2, 1, constant. Constants always go last, okay? Now, I know this is a lot of information and we're totally going to practice, but here's a good way to practice. We have this chart here, right? And we're given some weird polynomials. We need to determine the degree of the polynomial, the classification using the degree, the number of terms, and then the classification using the number of terms. Okay, so let me walk you through the first one. We have -6. Now, we don't have a degree because remember the degree, I'm just going to kind of write it here, is the highest exponent. Well, we don't even have a variable here, so there is no degree. And when there's no degree, it's called a constant. Okay. The number of terms we have is 1. Now, classification using the number of terms. Remember, that is the monomial, binomial, trinomial. Well, since we only have one term, it's called a monomial. Alrighty. So next, we have this 125p. Okay, so my highest exponent, remember there's a little, oops, sorry, had my highlighter on there. Remember there's like a little 1 here. So my degree is going to be 1. And when it has a degree of 1, we call it linear. All right, so the number of terms I have is still 1, right? I only have 1 term there, so it's called a monomial. Alrighty, so next up, it looks like I have negative 13s to the first power plus 6. The degree is the highest exponent, so it's a 1. Oh, and let me use the same colors here, sorry. I like to keep it all color-coded. Okay, and when we only have the degree of 1, it's called a linear. All right, so now how many terms do we have, though? We have 1, 2. We have 2 terms. So because we have 2 terms, it's called a binomial. All right, so the next up, ooh, some new stuff, right? We have 2 terms, and we're looking for the highest exponent. Well, that's to the first power, but this one is to the second power. So our degree is going to be 2. And when you have a degree of 2, it is called a quadratic. Alrighty, so the number of terms we have is still 2, so it's going to be a binomial. Alrighty. You get a new color here. How many terms do I have, though? I have 3 terms, right? Here's 1, 2, 3. So it is a trinomial. All right, next up, we have 2x cubed. All right, we're looking for our highest exponent, so our highest exponent is going to be 3. So therefore, when you have the highest exponent of 3, it is called a cubic. All right, so I still only have 1 term, so it's called a monomial. Alrighty, next one, we have 78j cubed minus 3j to the first power. All right, so my highest exponent is going to be a 3. So that means it's called a cubic. And I only have 2 terms. Oops, wrong color. I only have 2 terms, so it's a binomial. All right, last up, we've got, we get a new color here. Are you guys in suspense of what color I'm going to use? Ooh, and you'll see it in just a second. We have 8x to the 4th minus 2x cubed plus 3x. So we're looking for our highest exponent. It's, well, we got 1, 3, 4. So when you have a 4th degree, we're just going to call it a 4th degree. So basically, anything that's bigger than a 3, so anything that's bigger than a cubic, we're going to call it 4th degree, 5th degree, 6th degree, 100th degree. And then we only have, how many terms do we have? 1, 2, 3. So it's a trinomial. So what's really cool, let me give you some little insight on what we're going to be doing tomorrow. You're going to be given something like, let's say, 8x cubed minus 6x squared plus 10x minus 100. And I'm going to ask you, I'm going to say, hey, what is the official name of this one? Like, what are we going to call this? The first thing you're going to do is say, okay, the highest degree is a 3, so I know it's a cubic. Okay, and then let me get rid of the 100 here for a second. Okay, so I know it's a cubic. Let me rewrite cubic. And then you're going to say, okay, and I have 1, 2, 3 terms, so it's going to be a trinomial. So the official name of this polynomial is a cubic trinomial. Isn't that really cool? All right, let's look at this exit slip and see how we do. I would like you to pause the video, read this, and see what you think. See what you come up with, okay? So let me read this. We have Allie says that 3x squared plus 4x minus 1 is a polynomial of degree 1 because 1 is the greatest exponent. And it is a trinomial because it has 3 terms. Luke says, no, it's not a polynomial at all because the power of the first term is not a whole number. Who is correct? Well, I'm going to tell you who's correct. Luke. Luke is correct. Luke is the winner. Okay? Because if you have a polynomial that has like 3 to the x minus 2, like in this one, this is not a polynomial. Okay? So same like if you had 3 over x, or x to the negative half, or x to the 1/2, or x over y. These are not polynomials. Okay? So describe why each expression is not a polynomial here below. We have 4 over x. Okay? So because there's an x in the denominator, x is in the denominator, so not a polynomial. Okay, you also have this. So fun fact, x, the square root of x, is also, you can rewrite it to say x to the 1/2. These are exactly the same thing. Okay, so because the exponent's a fraction, not a polynomial. So fraction as exponent, so not a polynomial. All right. So if that was a little much for you, I would erase and try this chart again. Just try it one more time and put that all together, because I know you had a lot of vocab coming at you today, and we're going to practice more tomorrow. All right. See you later, guys.